Hello all. Welcome to the section 8.3 lecture video. So what we're going to do today is just go through how to solve systems of nonlinear equations using the methods we've already talked about. So all the methods we're going to use in this section, we're in section 8.1. So my plan is to just run through a few quick examples of how to do these using the graphing calculator app ClassCalc, and also how to do these by substitution if you so choose. But the basic idea in this section is that we're taking all of the things we've learned in this class. So first of all, the methods for solving systems, and then the methods we've learned in previous chapters of how to solve different types of equations to solve these systems of nonlinear equations. So here we go. So you can go and take out your notes and turn to page number 7, and we'll go and get started. So first off, before we get to the graphing, let's just talk about this idea that I could solve these using methods we've talked about before algebraically. So for example, this first equation here, I could use the substitution method to solve, because this equation, y equals x squared, will allow me to substitute x squared in for y in the first equation. So that'll give me 5x minus x squared equals 6. And then we could set one side equal to 0, so I'm going to add x squared to both sides. So this is 5x equals x squared plus 6, and then I'm going to subtract 5x from both sides. So this is 0 equals x squared minus 5x plus 6. And now we can use the techniques we've learned for solving quadratics, right? That's just a quadratic equation. So we could try to factor this. So we could look at 6. So numbers that add to get multiply to get 6 and add to get negative 5 could be negative 1 plus negative 6, or negative 2 plus negative 3. And this second pair works. So this would be 0 equals x minus 2 times x minus 3. And so then we could set each of those equal to 0. And we get two options. So x equals 2, or x equals 3. Okay, and so now we can substitute those two options into the first equation to get their y. So y equals 2 squared, y equals 3 squared. So y equals 4, and y equals 9. So we get the order pair 2 comma 4, and the order pair 3 comma 9 for our solution set. Okay. So that's the idea. That's all you have to do to use substitution, is you can substitute and you can use the methods we've talked about to solve these different types of equations. Right? These are all types of equations we looked at before. But maybe an even easier and quicker way to solve most of these, if not all of them, is just to graph them, right? We've talked about how the graphing can solve these. So like, for example, we could graph the next one. So if I graph y equals the absolute value of x minus 1. Okay, so we get that equation. And then I graph 2y minus x equals 1. I can click on these points where they intersect and get the solutions really quickly and easily. So negative 1 comma 0 and 3 comma 2. Okay, so that's all there is to solving equations like this. Okay, we can even do this for more complicated things. Like these are equations we're not used to dealing with. These are kind of weird looking equations on page number 9. We don't know what type of equation x times y is, but we can try using the same methods we just talked about. So I could try graphing it. Right, so if I'm on page number 9 here, I could graph x plus y equals 10, and we could graph x times y equals 21. And this should graph both of these for me. And if I look over here, I can zoom out a ways, but if I look over here, I should be able to get the intersection points just like we did before. So 7 comma 3 and 3 comma 7. Okay, 7 comma 3 and 3 comma 7. So even strange, kind of weird looking equations that we're not used to, we should be able to still graph these. Okay, so like if we tried one more, well, maybe we'll try 2 more. Let's try the bottom one here. Okay, so if I graph those bottom 2 equations, those seem pretty odd. So 3 divided by x squared minus 5 divided by y equals 33. And then the other one is 5 divided by x squared plus 1 divided by y equals 83. Okay. And if we zoom in the center here, we should still be able to find their intersection point. So we've got 0, 0, which I don't think is actually going to be a solution to this system, because if you plug in 0 into either of these equations, you get undefined. So we can ignore that one. And then we've got some other ones that are fractions. So I'm going to zoom in here so I can see which one is actually the intersection, hopefully. It's actually giving me the one over here, but the one on the left is the intersection. So that comes out as a decimal, but that's a decimal I recognize. So that decimal is negative 0.25. Well, 0.25 is 1/4, and that's 3 repeating, which those are both decimals I recognize. And then the same one should happen over here, but for some reason it's not showing up right now. Okay, there it was. So same thing on the other side. I get those 2 intersections, and I think that's going to be it. Okay, so the solution here for this one is negative 1/4, comma 1/3, and positive 1/4, comma 1/3. And if you're ever not sure about a decimal, remember you can always try and plug it into your calculator and see what you get. So like if I go back to if I switch to my scientific calculator and I put in 0.6 repeating, and I try to change that to a decimal fraction, it will for me, right? So that's 2/3. Okay. And so that's all there is to this section. Pretty much all the ones you can do in this section, you can do with the calculator. You can even do ones that involve logarithms and stuff like that. Okay, if you wanted to solve these systems, we could try doing that with the calculator. So like if I did the third one on page 11, we could try that out. So let's go to the graph. So the third one on page 11 is the first equation is y equals log. And remember, to get the log with a different base, you want to go to algebra and choose log b. So I'm going to do log base 2 of the opposite of x. Okay, so there's that one. And then I could do y equals algebra log base 2 of x plus 4. Okay, and we get the solution, which is negative 2, comma 1. Okay, so like I said, that's it for what we need to know in 8.3 is the idea that you can use substitution. I didn't do any addition ones, but you can use addition 2 and graphing to solve systems of any types of equations, not just linear equations. So that's it for chapter 8, and this is the end of the last lecture video, so make sure you do your last few homework assignments. If you have any questions, call, text, email, all those are great ways, or check in with my office hours.